All right, well, thank you very much for inviting me to talk with you today. What I'm going to focus on is teaming with autonomous systems. And we are seeing we're seeing a lot of attention recently in automated systems in a variety of areas. Autonomous vehicles on the roads are, of course, one thing that's getting a lot of public attention, but we're also have very heavily invested in new system autonomy for everything from space exploration, satellites, unmanned air vehicles for the military, cyber operations, really a wide variety of areas that are all latching into the newfound interest in intelligent systems and AI. That's really forming the basis for where we're going with trying to develop system autonomy. And this isn't really a new thing. For those of you who've been around a while, this is really a continuation of a trip that's begun, many, many years ago. Back in the 80s, when I first started working on AI and how it was going to affect our systems, we were mainly dealing with rule-based systems or case-based reasoning. A lot of work's gone on in Bayesian networks, and then really around the late 90s, learning algorithms became very common, and that's where we see the real push right now is in AI that's really based on learning systems and learning technology. Now, one thing I want to point out about these techniques is that the techniques are improving, but we still have a huge challenge in that the software is really only going to work for a very limited set of situations that it's been programmed to handle. Even with learning systems, it's not like they're like you and I, where they're learning on the fly. They really only can operate within the realm of the cases they've been trained on, and they get trained on large cases of data. So what we end up with are AI systems which are inherently brittle. And by that they're really limited to the rules or cases or training data that they've been set to handle. Secondly, we see that today's AI systems are really still largely limited not by the logic, but by their ability to do perception in a noisy world. And this is no small part of where their main limitations are. Even tape or mud on a stop sign, for example, can lead that stop sign to be completely misinterpreted as a speed limit sign or something else. Things that you and I would not see as a problem, the AI does. And so even at a basic perceptual level, that's still limiting their ability to operate in a lot of environments. But the third thing I think that's really problematic about today's AI systems is that they lack a model of causation. And there's a really good book called The Book of Why by Pearl and McKinsey that I recommend for anybody who's interested in this. But Judea Pearl is one of the bigwigs in the AI area, and he says he really goes into what the limitations are of these AI approaches, in that they're basically learning pattern matching. If you look at learning systems, they just learn patterns and recognize those patterns, and they're good pattern matchers, but they don't have a model of causation. And without a model of causation, you can't really project what's likely to happen. You can't do a lot of things. All you can do is recognize situations, but you can't project forward. And it's this model of causation is really important for how people do logic and reasoning in the real world. And so he feels that even today's AI systems are not going to overcome this particular hurdle. So that's just a backdrop then to where I think that takes us in terms of what we need to be doing from a human factors standpoint. And the real question here to me, when I look at this from a standpoint of situational awareness, is the inability of these systems to project. So not only are they going to be limited in their ability to understand what's happening, but they're not going to be able to project. If you or I saw this soccer ball roll into the street in front of us, what's the first thing that comes to mind? It's going to be, oh, there's going to be a kid chasing behind that ball. We better slow down and watch out for that kid. The AI systems can't do that. They don't have that kind of a reasoning system to think about what something like this might imply. And that's a fundamental limitation. When I look at how are autonomous vehicles doing today, I decided to take a look at the data sets. First of all, if you look at human drivers, and I looked at NHTSA data, And you find that the average human driver goes somewhere between 491,000 miles between crashes, and over 95 million miles between fatal crashes. So that's sort of the state of the art, I would say, for human beings. If we then look at how are intelligent vehicles operating today, we don't really know this because the vehicle manufacturers don't release this data, but in the state of California, they are required to publish disengagement data. So just looking at several years worth of reports, you can see that the Google Waymo car, for example, is doing extremely well compared to other vehicles in terms of improving its ability, its number of miles between disengagements. But last year's data showed about 13,000 miles before either it couldn't handle it and disengaged, or the human had to step in and disengage. So when you compare that back to 491,000 miles for a human being, you can see just how far these cars have to go. And most of the other vehicles are, significantly worse than that. This new company, Beidou, actually had some pretty high numbers all of a sudden, but I think those were under very restrictive testing circumstances. So the upshot of this, and the point I really want to make, is that before autonomous vehicles are able to be in this high-level, fully autonomous mode that I think their makers envision, they're going to have to be a whole lot safer than they are today. They're going to have to be able to handle a much wider variety of circumstances. And until then, we're very much going to be in a situation where human drivers have to be alert and able to intervene when needed, because they're simply not going to be able to handle the wide variety of circumstances that we see in the messy real world. And the question that I have is, are people going to be ready for this? Will they be ready for the unexpected? Will they be able to intervene when the unforeseen happens and you come around the corner and you're confronted with this? Are they going to be alert and in the loop and able to respond appropriately? And that's, to me, the big challenge of automated vehicles today. So the first thing I want to point out is, and a lot of people think, oh, once we automate things, we don't need situation awareness. But as I'm trying to illustrate here, we very much do need situation awareness. Unless they are 100% capable, we're very much going to need situation awareness in order to be able to oversee what it's doing and to intervene when needed. And we need awareness of a number of different things. Not only do we need to understand the environment around us, we need to understand the state of the task. Where are we in terms of our navigation or lane change or what have you? Where are we at in terms of what we're trying to do? And then we have the additional task of trying to understand what the automation is doing, and is it going to be capable of handling this particular situation at this particular point in time. And so what we've really done is we've added an additional burden to the human to understand and oversee the automation, in addition to what they were already doing in terms of driving that car. And then the question becomes one of how well are they able to do that? So generally, we see that people who are trying to oversee the automation are asking themselves some very basic questions. What does the vehicle know or not know about the situation that I'm in right now? What is it actually doing in a real-time sense, and why is it doing it? In other words, what is its current goal or tasking, or what logic led it to do that behavior that it's doing? What will it do or can it do in the near future? And what are the real limits of its performance? Is it going to be able to handle this kind of a situation that I'm in now, or that I'm coming up to? Or do I need to intervene? And the challenge that we have is, how well does our interface support us in making those kinds of decisions? One of the things that we see historically in looking at automation and automation-related accidents is that people often have a poor understanding of the automation state and what it's doing. And so Earl Wiener, way back in the 80s, was telling us that pilots were asking, what's it doing? Why is it doing that? What's it doing now? And that we saw this even among highly trained pilots who'd been operating with automation for numbers of years. They still were getting what we call automation surprise. And their ability to project that behavior of the system is really key to successful teamwork. To me, automation surprise is the opposite of situation awareness. I'm surprised because I didn't project that that's what it was going to do. I was inaccurate in what it did. And that's really what we need to be able to try and build up, is this ability to have a good projection of what the system is going to do. As an example, a few years back, I actually went and purchased a Tesla Model S. I had been studying automation in uh, aviation and in other domains for many years, and they were starting to come out in automobiles, and I really wanted to understand better how well those lessons from aviation actually applied in driving. And when I bought my Tesla, the first thing I learned is that there was absolutely no training in the automation purchase. The very nice young men took me around, showed me the various features. I asked the young man, so how reliable is the automation? And he said, oh, 100%. I said, really, 100%? He said, oh yes, 100%. And I came back to that question like a couple of times later, and really, it's fully reliable. Oh yes, fully reliable. And finally, he went and got another fellow to come in and said, oh well, no, not exactly. It kind of doesn't do this, and it didn't handle curves, and so forth. And it turned out that the first fellow who was training me had been on the job for 3 weeks, and the experienced guy that he brought in to train me had been there for 3 months. And so what I really learned from that is that the automobile dealers don't really have a system in place for training automation. They think of it just like they would a normal car handoff, where they're showing you where the fuel gauge is or something. They really have not come up to speed the way the aviation community has, with the need to really develop good mental models of how automation works. So what that means is I've pretty much been on my own doing trial and error to try and figure out what it does and what it doesn't do under different circumstances. And I've had a really focused, effort on doing that. I worry about drivers who maybe didn't have my background in understanding automation and automation limitations, that how easily fooled they could have been by this lack of training in buying these kinds of systems. The second thing I learned is that the software gets updated in my garage about once a month. So at night, it'll come on and it'll update the software, which has been great, but it's added all sorts of features, and I haven't known what those features are. You get a little set of software release notes that are not terribly informative. And so I've been surprised by saying, oh, when did it learn to do that? And what's it going to do? I have absolutely no idea. And I've come to the conclusion that the engineers who provide the software may not actually know either, because it's very much hidden back in a black box. So all kinds of surprises there. Again, no training. And I found many instances of mode confusion. That was actually when I ran this 6-month study of how did the Tesla affect my situational awareness and trust and performance. One of the things I documented on each and every trip was, what sorts of problems I had. And I found all sorts of mode confusion problems. It was very easy to confuse the lever that adjusted the automation with the turn signal. They were right next to each other. And so I was constantly trying to turn on my turn signal, and instead I sped up or slowed down, or vice versa. It was really weird. I would do things like take over the steering control to exit the highway and find myself still going 70 miles an hour, because the taking the steering wheel would turn off part of the automation, but not all of it. It wouldn't turn off the ACC, the acceleration control. So all sorts of weird things that were unexpected in terms of its behavior. You would get weird speed surges where, depending on whether the highway was divided or not, if it suddenly went to a divided highway with a median down the road, then it would let you go faster than if you went to where the lanes, we didn't have a median. So you would find yourself going along, and then suddenly it would surge on you at these unexpected times because of what was going on externally in the environment. I'm sure it made sense in terms of its internal logic. It didn't make sense from a standpoint of a driver seeing these weird behaviors. And then it had the interesting situations it couldn't handle, like coming around a major curve in the freeway, and it decides it can't handle that curve, and I get a tiny little beep beep, and it just turns off. And that's very frightening, going on a highway at 70 miles an hour where you've got traffic all around you, to suddenly have it turn off on a curve. So weird things. At one point I was driving along, and I saw a large RV in the next lane. It's getting closer and getting closer, and I'm thinking, this is really strange. And then I look forward and I realize the lanes are merging. And That's when I learned it doesn't know how to do lane merges. I had no idea before that. It did not know how to handle a lane merge, so I had to slam on the brakes. Luckily, I was paying attention and was able to do so successfully, but I can certainly see many of those circumstances having gone badly. And that comes to my real challenge with automation. And one of the reasons I started looking at this problem 30 years ago now is this whole issue of being out of the loop. And I was worried about this in aircraft, where we were looking at adding AI to fighter aircraft and people being out of the loop. And the same problem we're seeing now in vehicles, where basically, fast forwarding through all of that research, we know that people have low situation awareness when they're monitoring automation. They're both slow to detect that there's a problem and then slow to figure out what's going on in order to be able to take over appropriately. There are a number of reasons for that. Some people say it's just because they're not being vigilant and not monitoring, and that's certainly some of it. In other cases, that people aren't provided the information that they need to do this effectively, either intentionally or unintentionally. But then the third problem that I have found in really going through the research and trying to resolve these things is that even when we know people are being vigilant and we know they have the information that's needed, we still see this lower level of situation awareness. And it comes down to this lack of engagement. And that is that when people become passive processors instead of active processors of information, they just don't have the same understanding of what's going on. And I liken this to, if you go to a party with somebody and you're the passenger, and at the end of the night, you find out you're going to have to drive home. Did you have as good of understanding of how you got there as you would have if you'd been the driver? And I think most of us would say not really. You're just not paying the same kind of attention when you're passive instead of active. And that's really what we see with automation. It's turning us into passengers instead of drivers, and we approach the task differently. A lot of this research now is flowing over into cars, into automated vehicles. One of the things we've seen that is also particularly frightening is that people are 2.5 times more likely to be doing secondary tasks when they're driving with automation in the vehicle. So things like texting and talking on phones and all the other things. And I have to be really honest, even with all I know about the dangers of being out of the loop and the dangers of automation, I find myself drawn to doing bad behaviors in ways I never was before. And the reason is because it's very seductive. It works very well so much of the time that you really get lured into this false sense of security that, it's going to do fine. And so, I'll get distracted easily because it's bored. We've turned a boring task into even more boring task. And this is a fundamental problem. We're not going to get through it with training. It's something we're going to have to fundamentally work out about how we design the vehicles to keep people engaged and not disengage them with the way we're doing the automation. So let's see where we're on time. All right, let me kind of go through some of this. One of the things I did recently was a review of the literature in this area and what we know about automation. There's 2 scales of automation. They're very similar. One that David Kaber and I developed, and then a later one that Parr Sermon and Wickens and Sheraton did. And there's some slight differences in them, but basically they look at what stage of processing is being automated. Is it situation awareness, where you're gathering and integrating information? Is it decision making, where you're deciding what to do, or is it implementation? And looking at the research, I did a review, Onash et al. Did a review. We found that basically the effect of the automation on the performance really varies on depending on what part of it is being automated. And so normally you can think of situation awareness, decision making, and control execution as being really tightly integrated with each other. And what actually happens when you automate part of it, you disengage from that, the rest of it. So for instance, when we automate task execution, it's now disengaged from your essay decision loop. And we find that that's okay for very routine, repetitive kinds of things where people aren't going to need to intervene. But if they do need to intervene, then we find that they have lower situation awareness and out of the loop problems, particularly when there's a lot of advanced queuing of tasks or continuous control tasks. So for example, your route following, route navigation is an example of advanced queuing. We've set up that route in advance, and I'm going to be out of the loop if that has been automated. And we also find that people have a big increase in workload when they do need to intervene. So there's this re-engagement cost essentially when you disengage control execution from this SA decision-making loop. When we look at decision making, and that is sort of this idea of generating the what you're going to do and selecting what you're going to do. I originally thought that maybe whether you were involved in having to approve it or just veto it, that might make a difference. Turned out that didn't matter at all. What really matters is being actively engaged in generating options. Again, what we've done here, though, is we've disengaged the decision-making from situation awareness. And so we, again, see a re-engagement cost. When people have to jump in, they're slower to understand what's going on because they have to compare their gathering of the information in the environment to what the system has recommended they do. And that takes a re-engagement cost. It actually slows them down to do that, often without a real benefit to performance. And the real challenge there, of course, is that we see a decision biasing problem. So if the system is correct in recommending what to do in like decision support systems, for example, then all is well. But if it's wrong, it's much more likely to lead people astray than if you had just left them alone. But the last case is where we're looking at automating situation awareness. And here you never really automate SA, but what you do is you provide a lot of support to monitoring, integrating, and gathering the information where they need, reducing unnecessary searching and sorting through information, and working demands, having to integrate information internally. And what we see there is there's no disengagement cost and no re-engagement cost. So you get significant benefits for integrating information to support higher levels of situation awareness, comprehension, and projection. And you get some benefits when you do queuing if it's correct again, but it leads back to decision biasing if it's incorrect. So based on all of this, what I proposed was what I call the automation conundrum. And that is that looking at the last 30 years of research on how people interact with automation, basically the more automation we add to the system, and the more reliable and robust that automation is, the less likely it is that people overseeing the automation are going to be aware of critical information and able to take over control when they need to. And that's a really difficult situation to be in, because what that's saying is the more we add, meaning higher levels of automation, or the more functions we automate, or the more time we spent under automation, or the more granular that is, then the worse we're going to do in terms of having situation awareness of what's going on. And further, we can't automate our way out of this. In other words, unless the automation is 100% perfect and we could ignore it and go on our merry way, just having better automation actually makes the problem worse, because if we go from 95% reliable to 99% reliable, we're going to be even more out of the loop for that 1% where it matters. So we have a fundamental problem here. And it's really down to problems with how it affects our attention allocation and how it affects our fundamental engagement with the processing of the information. Let's see, I want to make sure we leave enough time for questions, but I do want to just cover this model. I call it the HAZO model, the Human Autonomous System Oversight Model. And basically what it shows here is that it ties together a lot of the work that's been done in trust as well as situation awareness related to automation. And the dark blue boxes here these are the design aspects of the system that we can affect. So automation robustness and reliability fundamentally affect our trust in automation. The more we trust it, the less we allocate our attention to it. Also, if we have competing tasks and demands, we'll tend to trust automation more, whether we should or not. In other words, it may not be any more reliable, but we will still subjectively trust it more if we have other things we need to be directing our attention to. The amount of attention that we allocate to that system then directly transmits through this automation interface to create our situation awareness. So the quality of that interface then in producing situation awareness is going to be very impactful. And conversely, how much our situation awareness can affect then our attention allocation. So this is very circular. Further, the automation paradigms that we use in terms of level of automation, adaptive automation, and granularity of control all will affect things like workload, engagement, and complexity to affect our performance. I won't go into this in detail, but I just want to hit that essentially, in addition to this level of automation that I've talked about, how much automation we provide, which functions we automate, and when we automate, how much of the time we automate, all of those things will have a fundamental effect on our situation awareness in a task. Further, we have this whole issue that I think hasn't received as much research attention in terms of things like span of control, which has to do with, are people having to interact with the automation on very specific tasks, or you just turn over a whole functional set to it and let it take control? That again affects this, how much automation is being provided. And then control granularity. And so there's been work on things like playbook control and goal-based control, which are very low levels of granularity, whereas manual control is a very high level of granularity. So the more granular it is, then the more involved we are. The higher level of control, which we think is going to be much easier from a workload standpoint, though is also probably going to be lower from a situation awareness standpoint. So we see some real competition there in terms of what we're doing. The last thing I want to talk about is this whole idea of the interface that's part of that model. And this is where I think we as human factors engineers can have a significant effect in what's going on today in the design of these systems. And here we're looking at one, you're going to make sure the right information is being presented, and it's being clearly presented. Is it salient? For instance, do we have good salience and boundary conditions? And these are these conditions where the automation can and can't handle something. How salient is that to the driver that they need to be able to take over? And really a lot of it comes down to things like system transparency. Do we understand what it's doing? This is an actual Tesla display, and you can see the blue lines here tell me that it can see the sides of the road. It can tell me what vehicles it sees. It tells me what mode it's in. And it tells me what it thinks the speed limit is. So that's actually giving me quite a lot of information about what the system thinks is happening. But we still don't have other kinds of transparency that are needed to tell me what's it going to be able to do in this situation. Is it able to, does it see a lane merge or handle a lane merge? Do I know how to predict it's going to be able to do that, or be able to take this curve? And so we still need, I think, better information in terms of understandability and predictability so that we can have a real-time understanding of what the system is doing. Some of the implications of this model then for where we're going right now in terms of vehicle autonomy. First of all of the efforts that are going into improving driver situation awareness, I think, are going to be highly beneficial. So things like blind spot warnings, where you can see on the side of your car, it lights up now next to the rear view mirror. You can see if you've got a light there, then you know if there's somebody in your blind spot. That's a great example of providing better situation awareness to a driver. Collision warnings, lane departure warnings, speed indications, all of those things are improving driver situation awareness, and I think we're going to get a lot of benefit with very little downside to them. Things that are directed decision making. Again, they're going to be beneficial if they're correct, but you get decision biasing if they're wrong. And so all of us see this with our GPS route navigation systems now. We really like those. They save a lot of work. And they can be great when they're correct, but every once in a while, they'll lead us into a dead-end street where the roads have changed and it doesn't know about it, for example, and it leads us astray badly. And then we're going, wait a minute, what's happening? How did I get here? How do I get out of this mess? Because it doesn't have an accurate map for whatever reason. So they're great if they're correct, but if they're wrong, then we're definitely going to be in trouble. Mine had a bad habit of leading me through heavily dense downtown traffic at rush hour because it didn't understand, where the traffic patterns were. That's now changed, or it doesn't understand, what time the baseball game gets out. So you have to be able to combine your knowledge with its knowledge. Routine actions that don't require intervention, those are all good. Things like anti-lock brakes, automatic transmission. But things that are going to require they're basically taking vehicle control, and by this I mean steering control and both vertical and navigation. So your advanced cruise control and your steering control. Those are going to have actually going to have your greatest loss of situation awareness. And these are the things that they're actually automating first, and they're putting us most out of the loop because it's automating that that task implementation portion of the task, and it's again taking us back into this really boring kind of world where it's going to be very hard for people to maintain vigilance. Now, the driving automation community is working on this. That's what they've been focused on. I think our loss of situation awareness is going to be the worst at the levels we're at now, which are SAE levels 1 and 2, where they're trying to automate the vehicle control. The higher levels of automation, where they say, oh, we're going to have this all fixed because the system's going to know where its limits are and it's going to warn you and get the driver back in. That would be great if it actually works. I have doubts as to whether the automation is going to have sufficient self-awareness to be able to do that. But theoretically it could be better, but I think we're a long way away from having that. And so today's systems probably have us in the worst case for loss of situation awareness. And that's where we're basically standing at. So this is sort of our vision. This is where we're trying to go, is this synergistic human machine autonomy integration. So where you can shift back and forth between humans and automation in this very smooth, simple, seamless manner. We've been working on what does that look like and what do we need to do to accomplish that? And we think this integration between the human and the automation really has to be accomplished in a very different sort of way, where because we know that the people have to be very involved in terms of overseeing the system, in terms of intervening, but we also need to be able to effectively share and offload tasks between these team members. We need to be able to collaborate and coordinate. To do that, it's going to take what I call informed trust, not just trust, but informed trust and shared situation awareness. When you look at the trust literature, what we see is that people don't just generically have trust in something. They do it in a very situational basis. So do I trust it to operate now in these circumstances, or how well is it performing now based on what's going on? Is it working? Is it getting good data? Is it within its programmed envelope? Is its goals set for my goals? Those are the kinds of things that people are trying to assess in order to know whether or not I should be trusting it now. And I think we have to step back in the trust area and start looking at this in a much more situational factor, because I think the two things are very interrelated in that sense. One of the things that I've looked at is this whole idea of shared situation awareness. We've done a lot of it in looking at human teammates. What does it mean to have shared situation awareness for a human machine team? And when you look at how humans and autonomy needs to collaborate effectively, we see that they need to have goal alignment. We need to be able to dynamically allocate and reallocate functions based on what's going on and what their status are. We need to be able to communicate decisions and make sure that strategies are in alignment, and then coordinate interrelated tasks. All of those require having a certain amount of shared situation awareness between these two teammates. So we have a large literature base on how we form shared situation awareness between humans, which depends on having good mental models of shared mental models of how things operate and shared goal states and effective communication and collaboration. Can we also extend this then to computer systems to have computer models that will effectively work in some way that's consistent with human mental models? And I think we're a long way away from that. And then do we have effective information sharing and goal alignment? So this is where I think there are a lot of current research needs, is looking at how do we build this shared situation awareness between people and automated systems, such that your model of your teammate would have an understanding of what are their goals, what are the current functions and tasks they've been assigned, what are their strategies for doing that, what is their task state, and what do they know about the situation. And all of those things are going to be needed to support things like true collaboration, functional task shifting, task alignment, coordinated action, these hallmarks of effective teamwork. So I think this is where there's some real work still to be done. is in trying to better support shared situation awareness between people and automated teammates. So I will leave you with that and break for some questions. I do think that we have some real challenges still to address in terms of developing effective human autonomy teaming. That's going to be required to have system autonomy working effectively in various sorts of environments where we are envisioning it. A lot of this is going to depend on having good interfaces for having automation transparency, where people can actually have those shared mental models and shared understanding of what's going on, as well as more effective automation paradigms than I think what we're currently using. But there's a good research base there, and I know that many of you may be working on some of these issues, and I look forward to seeing the outcome of some of that. So I'll stop now for questions.